Have you ever stopped and wondered how your computer actually talks to a server on the other side of the world? It's not magic, not at all. It's more like a recipe. So today, using the legendary Bee's Guide to Network Programming as our cookbook, we're going to break down that whole process. We're going to build, from the ground up, a simple step-by-step digital handshake. Let's dive in. So here's our game plan for today. We're going to kick things off with a simple analogy, a digital phone call, just to get our heads in the right space. Then we'll get our hands on the key ingredients, things called sockets and addresses. After that, we'll walk through the instructions, first for the server, then for the client, and finally, we'll see how the conversation actually begins.
To really wrap our heads around this whole thing, we need a simple way to frame it. And honestly, the best one out there is to just think of it like a good old-fashioned phone call.
Think about it, right? When you make a call, you follow a clear sequence of events. You pick up the phone, you dial a number, you wait for someone to answer, you talk, and then you hang up. As we're about to see, network communication follows almost the exact same script. The names for each step are just a little more technical.
Okay, so every phone call needs a phone. It's the most basic requirement. Well, in the world of network programming, our phone is something called a socket. And it's the very first thing we need to get our hands on to start this recipe.
So what exactly is a socket? You can think of it as a special doorway for your application to talk to the network. When your program creates one, the operating system gives it back a simple number, which is called a file descriptor. It's kind of like taking a ticket at the deli counter. Your program just tells the OS, hey, send this data through ticket number 123, and the OS handles all the messy details of getting it out onto the internet. It really is the endpoint for the entire conversation. Now, sockets come in two main flavors. On one hand, you have stream sockets, or TCP. These are just like our phone call analogy. You establish a solid connection, and everything you send arrives in the correct order, guaranteed. It's super reliable, which is why we use it for things like web pages. On the other hand, you've got datagram sockets, or UDP. These are more like sending a bunch of postcards. You just fire them off. They might get lost, they might arrive out of order, but they are way faster. And that speed makes them perfect for online gaming or video streaming, where losing a few packets here and there isn't a total deal breaker. Okay, so we have our socket, we have our phone. But, a phone is pretty useless if you don't have a number to call. In networking, that phone number is really a combination of two things, an IP address and a port number. For decades, the entire internet ran on IPv4 addresses. These 32-bit numbers gave us about 4 billion unique addresses, which at the time seemed like an impossibly huge number. The only problem? We ran out. The solution is IPv6, which uses 128-bit addresses. And the jump in scale here is, well, it's pretty hard to comprehend. Just to try and put this into perspective, 2 to the power of 128 is 340 trillion. It's a number that's so big, it's almost meaningless. Here's one way to think about it. That is enough unique addresses to give 1 million separate internets to every single star in the known universe. So, yeah, the main takeaway is we are not running out of these anytime soon. So the IP address gets the data to the right computer. Think of it as the street address for a giant hotel. But how does the computer know which program, which room, gets the data? Well, that's where the port number comes in. It's the room number. For example, web traffic almost always goes to port 80. This is how the data finds its way to the right application every single time. All right, we've got our ingredients prepped. Let's start cooking. We'll begin with the server. That's the one who is just waiting by the phone for it to ring. And it has a very specific 4-step process to get ready for that call. I just love how Bee's Guide names these steps. First, the server calls socket to get its phone. Then it calls bind to attach that phone to a specific port number, basically saying, hey, I'm listening on extension 3490. Next, it calls listen, which is its way of telling the operating system, will somebody please call me? And finally, it calls accept. This is the part where the program just pauses and waits until a call comes in. When it does, accept is what answers the phone. Okay, so the server is ready and waiting. Let's switch over to the other side of the line. The client's job, the one who's actually making the call, is, believe it or not, even simpler. It just has to get a phone and dial the number. So just like the server, the client starts by calling socket to get its own file descriptor, its own phone. But after that, it only needs to make one more call, connect. It just passes in the server's IP address and port number, and that's it. The operating system handles all the hard work. Hey you is really the perfect description for it. And this right here, this is the magic moment. This is the digital handshake. The client's Connect call zooms across the internet and finds the server that's been patiently waiting in that accept call. And when those two meet, the connection is made. The TCP line is open, and both sides are officially ready to talk.
So, with the handshake complete and the line officially open, it's finally time for the actual conversation. This is the whole payoff, the reason we did all that prep work in the first place. And as Bija's guide so perfectly puts it, talk to me, baby. There are two main functions for this part of the conversation, and they are about as straightforward as it gets.
I mean, it's incredibly simple. You use send to send data, and you use receive to receive it. But there is one absolutely crucial detail here. If your program calls receive and gets back a 0, it doesn't mean you received empty data. It's a special signal. It's the network's way of telling you the other side has hung up the phone. The conversation is over.
So why does all this matter? Well, because this exact recipe is the fundamental engine behind basically everything you do online. Every time you load a web page, your browser is a client connecting to a web server. When you play an online game, you're using these exact same principles, just probably with those faster UDP sockets. This digital handshake is happening all around us all the time.
And really, that's the core of it. A simple, elegant handshake that happens billions upon billions of times every single second, powering our entire digital world. The only real question left is, now that you know the recipe, what are you going to build with it?